I'm supposed to be doing the stereo cam. I will do it, okay, but when the sun goes down, I'll start doing the stereo cam. Well, we wanted to go think about the Robo again, and there was one last problem with it, and it said I have to sort of multiply the whole thing by how many parallel motor commands it's got to get the recording to work, and it slows it down a fucking heap. Like it was like I wrote that 64,000 thing. Oh, no, it won't. I know, no, it probably does, but I managed to get it to 4,000 by just putting more geometric invariance on it. So if you're learning new mechanical physics, you can see it's all geometry. So it's all mirrorable, flippable, and rotatable on the gravity axis. Yeah, it's like everything on the gravity. It's still true in all directions, but it has to be on the gravity axis. If you just want to record it, flat record it, yeah. That's the thing. Like if you're just going to flat record something, it's going to deal with like what it's going to be like completely, and you don't get any more than what it's going to give you. And it's about this permutation reduction. So I found that every transform you can apply to your data, you divide it by the amount of transforms, and that should be the perm reduction. It's a simple one. I was on my bed over there trying to think of it, but I think we just thought of it, yeah, it's by the amount of transforms. So if you've got like 2 to the power of 16, because you've got 16 motors, 1-bit motors, full left, full right, on H bridges, take into account the velocities, it's starting out of course, yeah. But you got to take into account momentum. But even if I just count if it's just full left, hard left and right coming out of the motor, that still is 2 to the power of 16 total combinations. And I can't do the motors in halves, I've got to do them all. And then you can see a big problem there, because you can't have too many hinges on the robot like this. But I still want to finish it. I've got it's not over for like the super one that's just everything. I think I also want to get this little one done first. So basically what I do is like, because the robot's one of them spiders, you can rotate them and you can flip and mirror them. And I get a total of 16 transforms, which should still be valid on the gravity axis. So that means the motor's controllers, bits, okay, they're actually interchangeable with each other on these transforms. And so I can do it with 16 times less perms on this motor command thing, and that sort of fixed it. But to do it, I have to complicate the matching system to work with flips and mirrors and rotates. But that's just a matter of swapping X with Z and inverting it, and inverting works with sums. And I went, oh, that's it. As soon as that was true, may as well do it. So it means that you can actually invert any amount. You can invert an exponential amount of numbers just by pressing space bar on the computer, just with one command on the computer. It's just one subtract to do an exponential amount of inverts. Isn't that funny? I know lots of quantum things like that. How just to do it on your computer. That's why you like the P equals MP thing better than the quantum thing. But it turns out thinking in qubits is good. It's good for it, because then you're just looking at powers of 2, and it's just combinations. But it's true that you can invert any amount of bits with just one subtract, all in parallel, but you have to accept it as a sum of the output. And the cool thing is the K&N matcher works with sums too, so this thing's pretty good. It's rolled into the quantum theory you were doing, but it's just for a first year neighbor match instead. But the cool thing is I can actually match flips and mirrors too, and rotate, so keep the coordinates separate, but I can still sum up the points themselves, so I can make the cluster codes for it.